This video will illustrate the methodology required to integrate a problem that contains trigonometric functions in non-standard form where you see products or individual functions, sines and or cosines, where both of the powers are even. Unlike where at least one of the powers are odd, where you can separate the odd power into a square power and a single power, that single power becoming the differential of the functions that are left that are raised to a power. When you have a square power, you can't separate it into a square and a single, and so you will never be able to get the differential of the other function. So you have no choice but to use an identity to rewrite the square power into a single power using an identity that actually changes the argument. And so in this situation, where you have sines and or cosines, you're going to use the following identities. Cosine squared can be rewritten as 1 plus cosine double angle divided by 2, or sine squared equals 1 minus cosine double angle divided by 2. In these cases, what you do is you replace for all of the square powers using these identities, and it will convert them eventually into single cosine functions. Notice it doubles the argument, but it converts them to single cosine functions which are a standard form. And so you substitute for all square powers you rewrite and simplify, and then go back to step 1. Generally, you will end up with a series of trigonometric integrals that are either a standard form or are directly solvable.